We all know the planting pass is one of the most important things that happens on our farming operation. And when you think about everything your planter does, the closing system itself and how we leave that field is one of the most important steps. When we think about what a planter can do, we can do good singulation or we can do good spacing, but leaving that field in a way that we're going to get good, consistent emergence is really what's going to drive throughout that entire growing season the yield that we're going to see in the end and the profit that you and I are going to see. So when we've looked at the closing system choices that are out there, we know there are plenty of choices, but they all are very common in how they're trying to close the seed trench. Those systems come through and they're trying to apply force at the top of the ground and push that sidewall from each side back together, doing its best to try to stitch the soil back together. Now that can be a challenge. If you leave an air pocket right above the seed, or if you start to find as you come back later that that soil was just slick enough and didn't want to stitch back together, it starts to open back up. There's all kinds of things like that that can start to happen that's going to detract from our emergence and it's going to pull back our yield. So while other closing systems can only work from the top down, we've come up with a brand new concept that we call pre-closing that flips closing on its head, thinking about how do we bring that seed trench back together from the bottom up. And that's with what we call 360 wave. 360 wave mounts in your row unit up right behind the seed tube and takes care of that seed right as it exits the seed tube all the way back until we hand it off into whatever closing system you prefer. We mount off the same bracket that your closing system mounts off today. We replace this green casting. That gives us our mounting location. And as you can see, the direction of travel of this row unit will be this is to the front and here's to the rear. So let's take a look at how 360 wave closes the seed trench differently, and then we'll talk about the different pieces of the wave design itself. We've got our sand bench here. The wave's mounted up here in front of our 360 Bandit that we use for nitrogen, and we're really looking up inside here to see how does this blade perform as we cut a trench with our row unit. And so you can start to see the difference right out of the gate with wave, and that's what the blade does for us. So our blade is coming through and cutting into this right sidewall. And why would we want to do that? Well, there's a couple goals we have. One is we know that we want to bring moist soil into the seed trench. And as you and I are setting our planting depth, we're going down till we find moisture. So we're bringing soil partway down that seed trench and bringing it into the center of the V, waving the soil over the top of the seed. And that has the advantage then of getting more moist soil right around the seed itself. The other thing that we like about bringing this wave in is now we've made the job of whatever closing system comes last a lot easier. We're providing loose soil that closing system can bring, and as it presses the sidewall together on each side, now that loose soil can fill in all the gaps and all the air pockets that you could end up with around the seed itself. So then as we're bringing this blade through, we're staying fairly close to that seed. We're 3/4 of an inch off to the side, and the blade is either at or slightly below the depth of the seed itself. And the advantage of that is it allows us to also have a key location where we can apply starter. We know starter needs to be close to our seedling roots. We want to get early interception of the radical root coming out of the seed itself and of our first crown roots coming out of that developing plant and out of that developing root system. So by being close to the seed, we get early interception. But the advantage of wave is we now have a barrier of soil between the blade and the seed itself, which allows you and I to run higher salt starters. We can run cheaper products. We can run higher rates because we're no longer putting starter actually on the seed. The seed itself is protected underneath the wave, but we're close enough that we see great response in terms of early interception of the roots and seeing that plant take off from that starter. So if we go in the sand bench and we actually cut this profile open, you can start to get a better view of how wave really engulfs this seed and starts to close this seed trench by bringing that moist soil in. So I'm going to go ahead and just remove what I disturbed with the shovel, where this is actually where the blade itself runs. So you can see further up into the seed trench, obviously the blade's up in here running on that right side. This is the path right here that the blade took, and it's actually gone into this sidewall and brought soil out and over that you see right here that's on top of where the seed would be. Now, of course, we're not dropping any seed. We're just pushing this row unit by hand, but this right here is where the bottom of the trench would be and where you would find the seed. So then if I start to come down this sidewall, this soil that I'm starting to move now, this is what we mean when we say a wave that's brought over the top of the seed. So you can always find where the depth of where that blade ran here, and this, all this soil that's right in this area is the soil that we've brought in from that right sidewall and started to bring over the top of the seed itself. It would be placed right here at the bottom where the seed trench used to be. The seed trench itself, and this is a good thing, it's not as clear that we see that V shape anymore because we've started that closing process. We've started to bring that soil in. So then as you think about the seed being placed here at the bottom of the V, you can see then where our starter position is really ideal. And we're off here to the side, right below where the blade ran. It's where we're depositing our starter. And that's that 3/4 of an inch over and at or slightly below the depth of the seed itself underneath this wave. So as our radical roots and our seed roots start to come out of the seed itself, we're close here to let those feeder roots do interception and start to pick up that starter. And then at the same time, then as our crown roots develop, we're right there ready to be picked up by that root system and really get that plant off to a good early start. So we'll go ahead and look a little bit closer at wave itself. So as we work our way from front to back and just looking at the components of wave, the first step is we firm the seed to the bottom of the trench. Before the blade ever arrives, the seed's coming out of the seed tube right here at the front. This firmer passes over the top, presses the seed to the bottom of the seed V. That helps improve our seed to soil contact right there, as well as ensuring that all the seeds are at the bottom of the trench, that we're getting consistent depth, which is another key component to getting good consistent emergence. We've managed how residue flows through the row unit with our trash shield up front. Anything that's getting kicked up off the opening disc itself gets caught along the bottom edge. You can see the wear protection here on the trash shield itself, and that gets carried forward smoothly right transitioning into the blade. So anything that you throw at this row unit just keeps flowing past. And then you have the blade itself that, as I showed you here in the sand, is bringing that moist soil over the top, cutting that wave over the top of the seed, pre-closing, and allowing us to apply starter here with the tube off the back. The other important thing when we thought about the wave design is making sure that we can run a blade this close to your seed and not cause any other problems. So the wave design has two joints. There's the blade pivoting joint, or what I call the ruddering joint, and then there's the rock joint that allows the blade to come up vertically. So the rock joint's fairly simple. We know some of you guys are going to run into heavy rock conditions. There's different obstructions that want to run through this row unit that we need to get out of the way for. And that's where the blade itself has a spring that keeps it set at the right depth. But if it needs to, this blade can pop up and over a rock, a couple inches of travel here at the tip. The other joint that I call the ruddering joint is even more important. So when you think about only being 3/4 of an inch away from the seed, we know that there could be scenarios where if the planter's going around turns, where if this blade wasn't able to pivot, as you can see as I'm moving it back and forth now, that the blade potentially could get close to the seed. So we've designed it with the ruddering joint so that no matter the scenario we're in, we always stay safe. So if you just follow through that and think through how that would work. If the row unit's traveling straight, it's really simple. This stop right here controls the placement of the blade. The blade's up against that stop, and it can't get any closer to the seed, which would be passing right under the firmer here along the side. In the case of if we were turning, say, to the left, that's pretty easy as well. The stop pushes the blade over and it actually moves away from where we've left seed here in the ground as this row unit drives away from you. And then in the case of any kind of curve or turn, as you're planning that goes to the right, if the blade was just fixed, that's where we would start to see the higher risk area, where the seed is here and the blade would start to move towards the seed trench. And that's where the joint kicks in, and the soil itself, because of the way the blade is shaped, actually drives the blade like a rudder so that it starts to turn away from the trench as the planter turns to the right. So this has allowed us to run a blade right where we want it for starter and for closing and not cause any issues with spacing or messing up the depth of the seed that's passing alongside. We've also thought about wear life. As I mentioned earlier, the trash guard's protected. The blade itself has hard facing, giving us multiple seasons of life. And we know that's going to vary depending on the soils you're in, but we're really happy with what we're seeing as far as wear. And the blade and the trash guard and the firmer are all easily replaceable. So let's go to the field itself, and we're going to go and follow a planter. And one of the tools I've really come to love is a leaf blower. Taking a leaf blower to the field can really teach you about what's going on underground. And you'll be surprised by the artifacts that get left. You can actually see the path the blade cut. Okay, to start with, let's look at row number 1, where we have a 2-stage controlled closing system. And we're going to use the air to blow open this row and take a look underground to understand what's really happening. How does it look at the surface, which actually looks pretty good, but the key is how does it look down near the seed where it really counts? So as we start to look underground, the real evidence starts to show up of how a closing system's performing. So here we start to see gaps near the seed. And you notice that the divots have been left from the disc up front in the closing system as they're trying to bring those sidewalls together, but it's not able to fully do it. So we're still seeing air gaps near the seed along the row here as we blow this open. So as we start to look closer, we start to see seed in those air pockets, and we know that anytime we have air around the seed, that's a risk for germination. That could cause us to have late emergers and yield loss. So we're looking for a closing system that's going to be able to bring those sidewalls together and be able to get full, complete closing from top to bottom. What we're seeing with the 2-stage closing system is even though it's controlled, it still has the disadvantage of working only from the top. So it's trying to push force down, it's trying to push force in from the sides, but it's not enough to really bring soil together and stitch it from top to bottom. So now let's take a look at our cast closing system. In the past, when we've looked at closing studies, the cast closing system's usually done a really good job. In many cases, in plots I've been part of, it's actually won the plot. So let's take a look here and see what we find. What we're seeing here is what we want to find. We're not finding our seam anymore. I don't see any evidence of where the sidewalls have been brought together. So I like how it looks right through this section. We do find a few spots here though that I still would be critical of. We're finding a void here, starting evidence of a void there as we've used some air on this seed trench. So some areas that we like, some areas not quite as good, but better than some of the others that we've seen. As we get down to our seed depth, right through here, I'm not finding much evidence of any kind of sidewall that's been brought together. So it's got a nice consistent closing all the way through. So as we work our way through here, we'll kind of find our next seed. Here we start to see a little bit more that's a little easier to get the screwdriver. And in fact, as I work in this void, I do find a seed here. So one of the good areas, we like what we see. Here I'm finding one spot that's not quite as good, but again, better than some of the other systems. We're now looking at what we would consider our standard closing system. It's what we're all used to seeing on planters, 2 rubber closing wheels running side by side. So as we look at our 2 rubber closing wheels, you get the thought that sometimes simpler is better. We're finding some areas that look okay. So right here in front of me, this section stitched together pretty well. Here I do have a void, here I have a void, so it's not perfect. We still find areas that could be better. And it's what we're finding throughout this whole planter so far. Every closing system we've looked at is all trying to work from the surface. All it can do is use our spring force that's on our closing system or an airbag, whatever's being used, to apply force down on the top and trying to pinch this sidewall together. And it just is sometimes out of reach. So as our topography changes, the closing system moves coming across here, we're not able to consistently stitch it back together, even though in some areas it looks okay. So on this row, we're running 360 wave. It's running out ahead of our closing system. We're firming in the seed first, then we're bringing our knife alongside, cutting moist soil out of our right sidewall and folding that over the seed. We're then able to apply our starter, and then after that, we just have a standard closing system. We're running 2 rubber closing wheels in spring position 1, followed by a drag chain. So let's go ahead and dig in here and see what we find. So now we've started to take the same view that we did before on our 360 wave row. We're looking at the same type of picture that we saw, but what's different now is this surface is looking a lot more consistent all the way through here. I like what I'm seeing, and what's happened here is we've given our closing system an easier job. The blade that's running up ahead has started to pre-close the trench, bringing moist soil over the top of the seed, making it harder to leave any voids through here. So there's some loose material to work with when our 2 rubber closing wheels come through to finish the job. And we start to see that here, where it's pretty consistent all the way through. So again, your bandit disc is here, your bandit disc is here. So right here through the middle is where we're gonna find our seed. As I work all the way across here, it's nice conditions all the way through, and I'm not finding any voids as I work all the way through here. So what we're gonna do next though, is let's go ahead and find the evidence of where the blade ran. So soil has memory. And we find that when we use the air. We're able to dig down, and you're gonna find the mark of actually where the blade was, and then let's start to uncover the seed. Okay, so you can see our blade mark right here along the right side of our seed trench. And what's good is there's not a lot of evidence of where the center line is. You really have to look close. You just see little glimpses now and then, like I get a little bit right here that starts to give me some evidence of where is the middle of our seed trench, where that left side has been left standing, and we brought moist soil from the right side over to finish out our closing. So as I work along that edge, you can go ahead and find the evidence like I see right here of our sidewall, and I can peel this wave now back towards where you're looking, and we should find seed as we work our way through. Look at all the moisture we've got in over the top of this seed, which is exciting for consistent emergence. We're going to get that seed to take off at a consistent time. We firm the seed down, so we're going to just have to work down to our seed depth, make sure. Right here I start to find him. Look how encapsulated on all sides that seed is as we work our way through. He's pushed in behind this wave. He's got a fertility starter being applied right here. He's going to be happy as he takes off. He's living the good life. Work our way through here. Jump up a few inches. Here's our next seed working along the sidewall where we'd want to seam. Same way here. We see those differences behind the planter. Now let's go into our plot and look for them there.
So Tim, we're here in this 60-acre cornfield where we brought our 8-row research planter in, and we said, let's come out and study the 360 wave in comparison to other things in the industry. Why don't you lay out for us the different things that we checked and what we're showing here today?
So we came in with our 8-row and we wanted to compare different attachments that we could have on that planter that are going to impact how that trench is handled after the seed is placed. And so that could be different styles of firming, different starter attachments, and then different closing systems. So here in the plot, we've got firmers up front, we have furrow jet that can be used to apply starter, we have different closing wheels from the rubber wheels we're all used to cast wheels, and then the dual stage controlled closing system, and we're comparing all of those to 360 wave. Now of course 360 wave can apply both starter and has the benefit of firming and closing. In the closing part of our study though, we haven't applied any starter, so we've kept that consistent all the way across the plot. What we're really looking for is how are we handling the soil? How are we taking our V trench and closing that around the seed using these different combinations of attachments?
So Tim, in this particular 60 acres, we came in here at this corn following soybeans at this Wiffles number, and we have 3 different soil types in this field. We have a sable, which is extremely sticky. That's the one that's always going to build up on your closing wheels. We have Ipavia, better soil isn't made in Illinois, and then we have a little bit on the hilltops here at Tama. But at the same time, a high yielding field, and then we come in really good conditions with a high-speed chopper harrow right in front of us. But then also we picked up a ½ inch of rain the next day after this plot was planted. So I would say, Tim, that if anybody was struggling on closing, that ½ inch rain will cover up a multitude of sin. So as we get started here, I'm really anxious to see what kind of numbers we're going to get.
So we're here today to look at what our harvest results are. But we were in this field earlier this year around V2, dropping tape measures and starting to compare what you're really going to want to look at with closing, which is what's our stand count coming out of this field and how consistent is it? Are we seeing late emergers? Are we seeing differences in emergence? So the team came in here at V2, we started to do those counts, and what we were seeing at that time is a 1.25 increase in good plants with wave compared to some of those other closing systems. So now that we're back here at harvest and we're at the finish line, let's see how those results compare as we go through and pull out this plot. So in this pass of our closing plot, we're looking at a controlled 2-stage closing system with a firmer out front. And one of the things we're doing to analyze our plot is looking at plant counts and late emerger counts. And what we're seeing here is we've looked at 9 replications of 1/1000th of an acre. So 9 times through the field, measure out 1/1000ths and going through and counting. And what we're looking for is either missing plants or late emergers like this, where we've got a smaller stalk and we're missing an ear, or we've got a couple kernels here that's really not going to pay us back. And as we walk down further, we've got another one coming here about another 10 feet later. Again, the same thing of what we're seeing here with this small guy that's really going to start pulling back on our yield. So what we're seeing as a total, when we average these 9 replications, is we've got 32.3 plants, and we planted 34,000. So we're missing a plant there that's just entirely gone, and we've got 0.7 per thousandths of these late emergers. So as we go through the plot, we'll continue to compare this data. So we've jumped over 8 rows, and now we're looking at 360 wave, which is our starter and closing attachment. And what we're finding here is an increase in ears. We're averaging 33 ears per thousandths, and we've reduced the late emergers, only 0.22 on average. So a good gain in ears and a reduction in late emergers. So let's take a look at what counts, and that's ears. We've got our ears here on the board. On the top we have 360 wave. On the bottom we have the 2-stage closing with firmer. And as we go to compare, we're seeing what we saw in our data. We've got our 33 ears up here, they're consistent, and we like what we're seeing. Come down below, and now we start to see the difference that counts. We're missing this ear that we saw in our data, and what we've got instead is this late emerger. And we know that's going to add up as we go across our plot. So in general, one missing ear is going to be 7 bushel, and let's see what that results come to be as we harvest. In this pass, we're still running the 2-stage controlled closing system, but now we've swapped the firmer for FurrowJet. And in neither of these plots are we running starter, but we're just comparing what's happening in the soil, what's happening in the trench, and how that affects closing. So doing again our counting process here, we're seeing 31.2 ears, and we're seeing 0.66 late emergers, like the one next to me here. So we're reducing the ears, we're seeing a reduction in ears when we take the firmer out of the picture, and we're seeing about the similar number of late emergers, 0.66 versus 0.77. So in our next pass, we're now looking at cast closing wheels with a firmer out front. And for years, this has been our baseline that we've always used in our closing trials. We've really liked what cast wheels have done, and prior to the 360 wave, it was our choice. Now here today in the plot, as we go in and we do our 9 1/1000ths again and we look at our counts, we're finding 31.2 good ears, and we're finding 0.55 late emergers on average per thousandth of an acre. So the wave numbers are outperforming it, but it's still a good baseline that we want to compare. Here at the top, we have 360 wave. I'll remind you of the numbers. We have 33 ears average, and here we saw 0.22 as far as late emergers per thousandth of an acre. So then here at the bottom, we have the cast with the firmer. And these ears are showing the big difference. To start with, there's 31 compared to 33 up above. These 2 ears are missing. We know that's going to make a big difference. And at the same time, we have more late emergers with the cast system, 0.55 versus the 0.22 of these small guys in a thousandth of an acre. More late emergers and fewer ears. So the final closing system we're looking at in our plot is just the standard rubber closing wheels with a firmer out front. We've gone in and done the checks and looked with the tape at our 9 1/1000ths, and we're seeing an average of 32.1 ears and 0.22 late emergers. So we've finished harvesting our closing study, and now's the time to dig in and look at the results. And I've gone through and broken out the data, and what we're doing here is we're averaging all the passes across the field where we had 360 wave, and that comes in as the top number in our plot at 251.2. And then we've gone through and averaged together any block where we had our passes with the different closing systems we're comparing to. And we just want to walk through and look at the differences that we're seeing. And I've got them ranked by yield as I go through and share these with you. So 360 wave again comes in at first, and then second in the plot we have the 2-stage closing system with the firmer. That's at 249.1, and we see a 2.1 bushel advantage to wave. And we know looking back and what we saw as we were analyzing these passes, we're seeing more consistent plants, we're seeing less late emergers, and that's showing up here in our yield differences. Third in the plot, cast and firmer. And we talked again earlier as we were going through this field of how the cast closing system often does well in our plots. We see that at third, 248.6. That's a 2.6 bushel difference to 360 wave. Fourth in the plot, rubber and firmer, our standard closing system a lot of us have on planters, 245.6, and that's a 5.6 bushel difference. And what's interesting there is when I tell you we're using 360 wave, all we have behind it is simple rubber closing wheels. And so the rubber and firmer versus wave is really the same closing tires, but we're seeing a 5 bushel advantage to the action that wave does in the trench of bringing moist soil in from the sidewall and helping us close. And then bringing up the rear is the 2-stage closing system in FurrowJet, 245.3, that's a 5.9 bushel difference to wave. So every plot you do teaches you something. And this plot is really showing us the importance of closing. And 360 Wave is performing at the best in this plot because of how it's different than other closing systems. It's a pre-closing system. It starts by firming the seed in first, by bringing moist soil in from the sidewall to be then finished off by the closing wheels. And that's making a difference in late emergers, it's making differences in good plants that we see, and it's showing up in yield. So as you look ahead to next spring and thinking about how do we want to upgrade our planters, 360 Wave is a great choice, both as a closing system and as an ability to add starter to that seed V and be able to get those plants off to a great start.